All right. So for today's lesson, what we're going to talk about is system of equations, how to graph them, and how to solve them. So we're going to focus more so on the graphing part for your test. So the very first thing we want to talk about is what is a system. So when we're talking about system of equation, it's when I have two or more of these linear equations. So these y equals mx plus b type equations, or in standard form, and then it's going to involve the same set of variables. So in our case, most times it's always going to be x and y. Okay, so what we're looking at is basically what is the solution of it. So when we're talking about solutions, this is what we're referring to. The value, if it exists, and we'll talk about when it exists, is that when it makes all the equations in this system true. And basically the big key part is where does the lines intersect. So we were going to talk about that coordinate, and basically when we're talking about where they intersect, we want to get you in the habit of basically telling us what that x comma y is, or where those two lines meet. And that's what we're talking about solutions. So the three different types of solutions that we're talking about is basically these three here. So the first one is one solution. So wherever it meets, wherever these two lines intersect, these two lines happen to meet at this single point, you're going to basically tell us what type of solution that is. So basically, what's the x and what's the y as a coordinate here. So when we're talking about that one solution, they intersect at a single point. So wherever they intersect, hey, I have one solution point. Now, what type of lines are these? Well, these are parallel lines. Well, will parallel lines ever cross? Oh, yeah, no. So basically what's going to happen is you're going to have no solution. So because they don't meet like this one, they're going to keep going in both directions, never intersect, never cross, and they're going to just keep running parallel to each other. So that's when you're going to have no solution. So there's really nothing you can write except for no solution. Infinite solution. So this one is kind of tricky in the sense of how many lines do you guys see? Okay, if you said one, okay, I kind of see that too. But what happens is it takes all the lines. You got one line here. Try to get as straight as I possibly can. And one line also here on top of each other. So what happens is they're coinciding. So what that means is they're overlapping. So what's going to happen is you're going to have infinitely many solutions. So meaning if I pick a point, it's on both lines. If I pick a point here, it's on both lines, and so on and so forth. No matter where I pick, I'm always going to have a solution because it's on both the lines at the same time. So that's what we mean by infinitely many solutions here. Okay. So let's apply this. Let's kind of see what this looks like so that we can graph it on here and see what type of solutions and then what's the solution point. So for your examples, let's go ahead and talk about it. So I'm going to basically graph this one in red first. I'm going to start with this number. That's my y-intercept. Okay. This number, that's my slope. Okay, so if I want to set up my slope, I want to do this over here so that we can kind of review this. So the very first thing I got to do is find this number, find this y-intercept number, this single number with nothing around it. It's just basically a simple number when y is by itself. So I'm going to basically plot that point, -3. Now, what this number tells us is our rise over run. So it's basically telling you how much it's going to rise or go up or down. And this bottom number tells you how far you're going to run always to the right. So this rise number, if it's positive, it goes up. If it's negative, it goes down. So for some of you guys, make sure you're reading your signs. I take a look. Hey, it's positive. It's a positive number here. Cool. So that means this is going to go up. So that means up 1 over 3. 1, 2, and 3. Okay, and then basically now that I have my 2 points, I can simply connect my line here. So I'm going to try to keep this nice and straight, carry this through, and there we go. So there's my first single line. So let's do it again with the blue one. I'm going to use this in blue. I'm going to look at my y-intercept. I see my y is all by itself. When I say by itself, there's no other numbers. There's nothing else. It's good to go. I'm going to circle my slope. How do I know its slope? Find the x. This is your x coordinate. This is your slope. So I'm going to rewrite my slope over here. Notice what I just did. I took that negative that was out front and I placed it with the top number, my numerator. So what that tells me is since it's negative, negative means I'm going to go down the bottom number always to the right. So now let's go ahead and start this. So +3, +3 here. Now I'm going to go down 1, 2, 3, 4, 5, and then over 3. 1, 2, 3. Now here's my point. Okay, so I'm going to get my little drawing tool with my line. I'm going to connect it from point to point. And then I'm going to take this and slide this up a little bit. And there's my equation. So basically, if you take a look, how many times do my lines cross? And if you said one, cool, that does have one solution. But to make sure you guys get this correct for your STAR test and everything else, what point does it cross at? So what I'm going to do is I'm going to start from my origin and go 1, 2, and 3. I'm right above it. And then go down 1, 2. So what happens is my solution type, what you guys want to type here, you have one solution, but we also have it at 3, -2. And this is very important for tomorrow's lesson, so that way you guys are ahead of that part. So how does this look in a graph? So easily, what I can do is I can just take my little calculator here and then plug these in just to see what that looks like. So I'm going to go ahead and minimize all my screens real quick. Tell that yes. I'm going to pull up my calculator like you guys have, and then show you what that looks like on your calculator here, so that way you guys can see. Do this for now. Next. And thanks. Okay, now here we go. So I'm going to maximize so you guys can see it a little bit better. Let's make this calculator a little bit larger. There we go. Cool. So y. So if I want to graph these two, I just do alpha y equals. So I can get that little fraction. I'm going to hit the number 1. So that would now have this little fraction. So it was 1 over 3 x minus 3, because it started at the negative. So minus 3 here. So I'm going to go down to my second one, and I'm going to do my alpha y equals. Make sure you guys are following along with your buttons on here. And then now it had a negative up front, so I'm going to put a negative 5 over 3 x, and then this one was a plus 3 here. And then we go ahead and graph. So perfect. So it looks like my graph. So if I want to compare it, yep, about the same here. Now, to find that intersection, I want to do trace. Second trace. And we want to talk about the intersect. So basically, I'm going to go to 5, enter. Hit enter once for that line, enter once for that line, and take a guess here. And you'll see that the intersection point is 3, -2. So basically that works for us. Now I want to fill in my table. So second graph, and now I can fill in that table that we have up here. So first part, -4 and 8. So I'm going to go back to my graph here. So this was 8. Oops. So this was 8. Let me go ahead and fill in my parts here. So 8, 19 over 3. 19 over 3. 14 over 3. Put that on the fraction line. At 0, it is at 0, it is at positive 3. 1 is at 4 over 3. 2, go down a little bit. It's at -1 over 3. And then for my other one, -4. And -11 over 3. And then -10 over 3, -3, -10 over 3, -3, 8 over 3, and then I gotta get my 2. -7 over 3. Now I want you guys to notice something. So as I go through and I'm looking at my values, so none of them match. So be careful this one. This one's a -3, this one's a positive 3. But if I were to go to that one single coordinate, do you see how it's at 3? My x is 3, this has -2, and this also has -2. That's when you know if I'm looking at a table, if they have a solution that are the same, because they're going to have the same y value. So if I want to continue this would have 3, -2. And this one here would also have 3, and -2. I can't write it because of that little bar. So that's my solution point here. Now, what about this one? So we're going to graph this. We're going to take a look. I'm going to start it off. So 3, I'm going to start out at a +3. Now, this I have to make it a fraction. So how can I turn a whole number into a fraction for my slope? Well, we just put it all over 1. This is my rise. This is my run. Is it positive or negative? Take a look. Go to positive, so that means I'm going to go up and to the right. Now, your star sometimes will do this. So good thing we had this for our example. So if I go up, 1, 2, 3, up, now I don't have enough room. So I can go back the other way and just try it this way. So if I start from a point over here, and I'm going to guess 1, 2, 3, 4 over 1. So basically my little point for this line will be located here. So I'm going to go ahead and take my little line tool, have my right color, and here's how straight that line is here. Now, what about if I have it for my second one? Take a look at my y-intercept, my little number here. Take a look at the slope. Turn that into a fraction. It's a 4 whole number, so put it over 1. So there's my rise, and there's my run. So what do you notice about the slopes? Yeah, so if you said that they're the same, so that's going to play a part in identifying what type of solution it is. So this one I'm going to start at -2. And this one, because it's positive, I'm going to go up 4, 1, 2, 3, 4, and over 1. So then I'm going to get my little line tool and connect and connect. So what do you notice about your solutions? Will they intersect? Yeah, so this one for our solution type is no solution. So I don't even have to worry about this part because they're never going to touch. They're parallel to each other. So they're going in the same direction. Their slopes are the same. And so basically, if I want to fill that in real quick, I can just simply put in this, and this would be -9. Type this in. I can easily put this in my calculator. This would be -5. This would be -1. This would be +3. And this would be 7. And this would be 11 after that. If I look at my other one, at 4, -3, so that would be -15. No, try that again, -14. So -8, -10, so that's -10. -6, that's -2. That would be 2, and then this would be 6. So basically, if you take a look, they're never going to come in. So this one's negative going here, this one's negative here, these are positive, so they're always going to be far apart from each other. So this is how we get that no solution example. Now, what about this one? So if I take a look, I'm going to do the same thing. I'm going to take a look at my last number. That's where I start down here, -5. And then I look at my slope. I see that it's positive, so that means it's going to go up and to the right. So from this single point, from that -5, so up and to the right. Up 1 over 3. 1, 2, and 3. And there's our single line here. Get my line tool, connect my points, and that's all we're going to have here. Now, take a look at that second one. So remember, is the y by itself. So we always have to go through it. Now this one, I notice here's y, but it has this +5. So what's going to happen is I need to do the opposite just to move this away. So a little bit of algebra work. These are going to cancel, so I'm going to rewrite this. So now it's y equals 1 over 3x minus 5, and I'm going to do the same process here. So I'm going to look at my starting number, my -5. Okay, that's weird. It starts at the same one. Have my slope positive up and to the right. So I go up 1 over 3. Now, what do you think about the solutions of this? I'm going to connect it here. Move this down here. So what can we say about these lines? Yeah, they're going to be the same. So what's going to happen is this is basically that example of an infinite solutions. So my equations, if you take a look at the equations from up here, y equals 1 over 3x minus 5, y equals 1 over 3x minus 5. So these two are the same. So this is how you get those infinite solutions here. Okay, so that's basically what you're doing for today. Use this video to help you with your assignment, and definitely use that calculator to check your work. Here's 2 practice problems to work on, and then we will go over it in class. And good luck.